Python provides several numeric types for different needs. Int are integers with arbitrary precision. You can have very large integers without overflow. Float follows IEEE double precision, that is fast but can display surprising rounding. For complex maths, Python has a built-in complex type. So a complex number 2 plus 3j has a real and imaginary attributes with dot real and dot imag. When exact base 10 arithmetic is required, for example in financial calculations, use decimal. So decimal avoids such binary float rounding. For exact rational arithmetic, use fractions. Fraction to represent p by q, for example, precisely. So here is a step-by-step example for decimal line. So decimal 0.1 constructs a decimal from a string to avoid float parsing error. Adding two decimals yield decimal 0.3. So this avoids the float, that is 0.1 plus 0.2 float is nearly equals to 0.30000 goes to 4. So left column concise. So Python is dynamically typed, which means you do not have to declare variables ahead of time, but sometimes you will want to manually convert between the types. You can do this by calling built-in type functions like int, float, str. For example, calling int function and passing 3.1415 maybe converts the float into an integer. But notice it doesn't round, it truncates the decimal part, leaving you with a 3. Next, str, let's suppose 3.0 takes floating point value and converts it into a string representation. Float converts a string that looks like a number into a real floating point value. So these conversions are often used when handling user input from the keyboard. Since input function always returns the text, you will usually wrap it into int or float functions if you want to do numeric operations. Strings in Python are sequence of Unicode characters and are immutable. You can index and slice them just like lists, but any operation that changes a string creates a new string object. String methods are plentiful. Dot split tokenizes, dot join concatenates and iterable efficiently, dot replace substitutes, and dot strip removes surrounding white space. When concatenating many strings, prefer dot join and you pass a list of parts for performance rather than repeated plus operations. Strings in Python are ordered sequence of characters, and each characters in that sequence can be accessed using an index. Here we start with the string s is equals to spam. When we call length function of s, Python tells us the length of the string, in this case 4 characters. Now Python uses 0 based indexing, meaning that the first character is at position 0, not 1. So s of 0 returns s, the very first letter, and s of 1 gives us p, the second letter. In addition to counting from the left, Python also allows negative indexing, which is an incredible useful feature. Negative indices count from the end of the string, like s of -1 refers to the last character, which is m, and s of -2 refers to the second to the last character, that is a. So positive indexes count forward starting from 0 and negative indexes count backward starting from -1. So this makes it very easy to access any part of the string without needing to know its total length. For instance, s of -1 will always get the last character no matter how long the string is. After indexing individual characters, let's move on to slicing, and this is one of the most powerful features in Python sequences. Slicing allows us to extract a subsequence from a string. Here's how it works with our string s is equals to spam. When we type s1 colon, then Python starts at index 1, the letter p, and takes everything up to the end. The result is spam. Notice that the original string is still spam because strings are immutable, so slicing always produces a new string, leaving the original one unchanged. Next, s of 0 colon 3 means start at index 0 and stop right before index 3. This gives SPA everything but the last character. You can shorten that even further. For example, S of colon 3 works the same way because Python automatically assumes the start index is 0. Similarly, negative slicing works too. Like for example, S of colon -1 means take everything up to but not including the last character. Again, you get SPA. Finally, S of colon gives a full slice, that is a copy of the entire string from start to end. This is often used when to make a top level duplicate of a string or a sequence. So remember, in slicing, the start index is inclusive and the end index is exclusive, meaning Python stops just before that position. This rule is consistent across all the Python sequences types, not just strings. We already know strings are sequence of characters, but another important property of the strings is that they are immutable. That means once a string is created, its contents cannot be changed in place. Let's explore this using our one familiar example. We start with s is equals to spam. If we write s plus xyz, the Python performs concatenation. It joins the two strings together, returning a new string spam xyz. But notice, the original s is still spam. The operation didn't modify it, it just created a brand new string object and returned it. If we check by trying to assign directly s of 0 is equals to z, for example, the Python raises a type error and the message clearly says that the string object doesn't support item assignment. That's Python way of reminding us that string objects are immutable. However, you can build a new string from the parts of the old one, for example, by taking everything except the first letter and prefixing it with a maybe letter Z. So this statement does the same. Now the new value of S is ZPAM. Essentially, you are not modifying the old string, you are creating a new one and assigning to the same variable name. Behind the scenes, Python automatically handles memory management and cleans up the old unused string when it's no longer referenced. So the key takeaway here is that strings are immutable, but names are not. You can rebind a name to a new object whenever you need to. Let's look at two more common operations you can perform with the strings, that is repetition and membership testing. First, look at repetition operator, that is represented with a asterisk sign. When you multiply a string by an integer, Python repeats that string that many times. For example, if you write s asterisk 3, this gives you this string with spam word repeated 3 times. So this doesn't modify again the original one, remember, as the strings are immutable. So instead, Python creates a new string that is a concatenation of 3 copies of spam. So this operator is really handy for the tasks like generating repeated patterns, in maybe formatting and creating separators in text output. Next, the membership operator. It checks whether a substring exits inside another string. A in S returns true if A is indeed one of the characters in or string that is spam. But Z in S returns false because there is no Z in our string. So you can also reverse the test using not in. For example, am not in S returns false because am is found inside spam string. Membership testing works not just with strings but with any sequence in Python like list, tuple or even dictionaries, where it checks for the presence of elements or keys. So X is for repetition, that creates multiple copies. In and not in are for searching within the sequences. Python strings come with a powerful set of built-in methods that lets us manipulate and search text very easily without needing any external libraries. Let's start with two commonly used methods, that are find and replace. Find method is used to search for a substring within another string. The method returns the offset index where the substring first appears. For example, s is equals to spam. Calling s.find PA returns 1. That's because the substring PA begins at index position 1. So remember, Python uses zero-based indexing. If the substring is not found, .find returns -1, which is handy for conditional checks. Next we have replace function, which creates a new string by replacing one substring with another. When we write s.replace, Python scans the string, finds the string PA and builds a new string that is SXYZM. Notice again that the original string hasn't changed, it is still spam. So this behavior enforces that strings are again immutable. Both the find and replace return new values without modifying the original object. So these methods are commonly used in real world tasks like searching within the documents or maybe cleaning or formatting data. So here find returns the first index of a string NA, that is 2. When we try to find X, it returns -1 because the substring doesn't exist. Replace method replaces all non-overlapping occurrences of NA with capital NA, giving this string, but again the original text remains as it is. Python strings are not just static piece of text, they come packed with powerful built-in methods that make text processing incredibly simple. So let's start with one of the most useful method, that is .split, the split method. Here we have line is equals to that string. When we call line.split and we pass comma in the split function as an argument, the Python looks for each comma and splits the string wherever it finds one. So you can see the result as a list of substrings. So this is extremely common when reading comma separated values during parsing data files or handling user input that comes in, for example, in a single line. Next is an upper function. Upper converts every character to uppercase, giving you all the string characters in uppercase. Similarly, lower would convert everything to lowercase. Now what if you want to test what kind of content your string holds? So Python provides a family of Boolean test methods like isAlpha, isDigit, isLnum. When we call isAlpha, it checks whether every character in the string is a letter and returns true. If s contained digits or punctuation, for example, it would return false. These methods are extremely handy in input validation, for example, checking that the user has entered only the letters in the name field or only digits in the phone number, for example. Here isDigit confirms that all the characters are of digits. isAlpha returns false because it includes numbers, but text.isLnum returns true since it contains only letters and digits. And when you use .split with no arguments, Python splits on white space by default, that is for spaces, tabs and new lines. Lists are go-to mutable sequence in Python. Use append function to add one item, extend to concatenate from an iterable, insert to put an item at a position, and then pop to remove and return an element. List comprehensions are efficient. For example, you can write this thing in a square bracket. So slicing L start stop creates a new list. It doesn't mutate the original. Note that repeating list with steric duplicates the references. If elements inside are mutable, they will be shared across repeated slots. So this expression inside the square bracket, as you are seeing on the screen, iterates elements from 0 to 5 and computes the squares, returning a new list with 6 values. So comprehensions can include conditions like this for events. For copying, use list.copy for shallow copy and copy.deepCopy function if you need to clone nested mutables.